Hi everyone. In this session, we will discuss on ML modeling at scale. How did we try to break the barrier to apply dynamic ML models at scale in production systems? I'm Supriya here. We have Prajwala and Nisha with us to discuss these points. We are all from Dell Technologies. Going to the agenda. So we will first discuss what is the need for ML at scale. And then we will take you through the introduction to automated machine learning. And automated machine learning has different implementations. So from those, we have chosen AutoGluon. So we will explain why we chose AutoGluon for our trials. We will discuss on its capabilities. And then, of course, we will look at the different problems, classification and regression problems that we try to solve using AutoGluon setup. Then we will be proposing an architecture on how to leverage automated machine learning in production systems. Of course, through our POCs and trials, we did face some challenges. We'll discuss those here. And then also we will discuss the next steps that we are planning to address those challenges. Over to Prajwala and Nisha for discussing the rest of the points. Thank you.
Hello everyone, my name is Prajwala. So coming to introduction to AutoML, which is automated machine learning. If we compare traditional machine learning model development, which goes through a series of steps like data processing, feature engineering, feature extraction, feature selection, algorithm selection, hyperparameter optimization, model evaluation. All these steps are time consuming, needing significant domain knowledge and system resources. While everyone dealing with the computer systems understands importance of ML for making the system intelligent, factors like demand for faster solution, restricted resource availability, lack of domain expertise, time taken for getting the right model from the plethora of algorithms, all these are impacting adoption of ML. Automated machine learning is a process of automating these time-consuming iterative tasks to speed up model selection and apply ML to real-world problems. This brings in addition advantage that non-experts can also leverage ML for solving the problems and may get a better solutions than hand-designed models. In this figure, which depicts steps in the traditional ML model development, which would get automated using AutoML. Here in the left side, you can see we need a human experts for defining the problem clearly and collect the required data, after which AutoML framework will handle rest of the steps, including feature engineering, model selection, optimization, and evaluation. After getting the recommended model, again, we need a human experts can use that model in the production systems. So AutoML helps to apply ML at scale using ensemble of algorithms. Again, we need a user inputs like data set, target metrics, and constraints like time and cost to be defined. This framework, the service iterates through the ML algorithms paired with the feature selections, where each iteration produces a model with a training score. The higher the score, the better the model considered to fit your data. It will stop once it hits the exit criteria defined in the experiment. We can also make use of a leaderboard to list all the algorithms with the rank and the score. Coming to the need for ML at scale. So in the industry, we can apply ML models to a given data set with the two approaches. One is a static models or a batch models. Models prepared outside of the production system using batches of data and are saved to be used with a similar data set in a production setup. Dynamic models, also called as online models, where models are trained online with the new data points or the data sets inside a production system. Both approaches have their own pros and cons. Static models are faster and easy to be applied, and whereas the dynamic models helps us to deal with the data trends in a dynamic way in our production systems, which requires a frequent retraining of a dynamic data set. To address increasing number of different problems like regression and classification, we need ML. Also, we can run these models with restricted available resources like CPU, memory, and time. We can obtain the accuracy within the required range. For example, if we have a user A and a user B, if user A requires accuracy which is greater than 50, and a user B requires accuracy which is greater than 90%. So which it totally depends on the user's data. And in the market, we have a plethora of AutoML frameworks, but we chose AutoGluon. To know why AutoGluon? Because it is open source library to create applications involving AutoML, and it is open source by Amazon Web Services. AutoGluon automates all of the iterative tasks, creating a truly hands-off-the-wheel experience. Rather than spending your own valuable time managing these experiments or learning how to do them in the first place, you can simply specify when you would like to have your trained model ready. And AutoGluon will leverage the available computer resources to find the strongest ML models within its allotted runtime. AutoGluon also enables you to automatically achieve the state-of-the-art performance on the tasks such as image classification, object detection, and text classification, and supervised learning with the tabular datasets, meaning it deals with the images, text, as well as tabular datasets. The hyperparameters of each task are automatically selected using advanced tuning algorithms such as hyperband and reinforcement learning. With AutoGluon, you don't have to have any familiar with the underlying models, as all the hyperparameters will be automatically tuned within the default ranges that are known to perform well for the particular task and a model, as well as easily extensible by ML experts. One added advantage with AutoGluon is it is available with Apache 2.0 license. With this, I request Nisha to handle the rest of the presentation.
Thank you, Prajwala. Hello, everyone. This is Nisha, and I will be focusing on rest of the topics for today's session. Let me start with capabilities of AutoGluon. AutoGluon enables us to leverage automatic feature selection, hyperparameter tuning, model selection, architectural search, and data processing. And it comes with the bespoke set of models in a predefined order. For example, random forest before k nearest neighbor. And this order can be easily tuned. And even you can customize AutoGluon as per your use case. AutoGluon comes up with the novel form of multi-layer stack ensembling, as shown in the image on the right side, where in the first line we can see we have multiple base models, and these models output are concatenated and then fed into the next layer, which itself consists of multiple stacker model. The stacker model act as a base model to an additional layer, and it aggregates predictions using weightage and gives the best outcome for our problem solution. AutoGluon further improves its stacking performance by utilizing all the available data, including training data and data for validation, through k-fold ensemble bagging of all the models at each stack layer. Currently, AutoGluon supports some set of algorithm, for example, random forest, extremely boosted trees, k nearest neighbor, cat boosted trees, AutoGluon tabular deep neural network, and light GBM boosted trees. If no hyperparameter tuning is done on AutoGluon, then it will run all of these on your data set. This way you can add, and as I mentioned, you can customize AutoGluon also. So you can add your own algorithm. For our trials, we did this for PLR, piecewise linear regression, and the integration was very smooth. So you can also customize AutoGluon. So this way we see that AutoGluon works efficiently for problems like regression and classification. So now let me show you how we are addressing these problems and what kind of use cases we are considering for this problem. First, I would like to address regression problems, where we are taking example of capacity projection, capacity projection is nothing but predicting when the capacity reaches 100%. So this way, if we get alerts or notification before our capacity reaches full, we can address this issue by migrating our data to another and freeing up some space. So this way we can leverage AutoML if we get prediction in advance. So for our trials, we are using data set of an enterprise storage system, storage capacity growth data set, and our data set is split into the ratio of 3:1 for training and testing purpose. Initially, it is having multiple columns, as you can see in the snippet of data set. Post data cleaning, we are using 2 timestamp and total post compression PCT. For our trials, herein we can see the results, what we got when we ran AutoGluon for this capacity projection problem. In the right side, you can see the metric, root mean square error, we got 2.44. MAPE metric, we got 0.04. Our train data was having 389 rows and test data was having 124 rows. On the left side, if you look at, we have plotted our results where orange line is for predictions and the blue one is representing actual data. And you can see the predictions are promising. So we can leverage this to predict capacity projection in advance in our storage system. I would like to focus here on the next problem which we are trying to address under classification problem category, which is called as disk failure. As disk plays a crucial role in data center stability, and due to exponential growth in data due to technology advancement, data centers facing this common problem that the nature of growth of data. So if we can predict that nature of growth of data, we can solve our problem very easily of disk failure prediction. And if we get notification earlier, then it will be very handy for us that we can migrate our data from malfunction disks to another valid disk. So for our trials for disk failure prediction, we are using community data provided by Backblaze Data Center, where we have self-monitoring, analysis, and reporting technology statistics. These are also called as smart stats, and these are collected during normal operations of disk. And this helps us to determine when disk failure become more frequently. And these stats also detects and report various indicators of drive reliability. There are almost 242 smart stats which Backblaze is collecting. Among those, the listed 5 we are using for predicting whether a disk is going to fail or not. So for our trials, we are using Q2, Q3, and Q4 data sets of 2019 provided by Backblaze. And let me show you what results we have got when we ran our disk failure prediction with AutoGluon. If you look at the result in the predictions and if you look at the ground truth values, you will find that our predictions are approximately matching to the ground truth. And on the right side, you can see we got accuracy of 99.89%. Our balance accuracy was 99.88%. Our train data was having 4,23,608 rows. Test data was having 1,33,772 rows. This way, we saw that AutoGluon is giving promising result within less amount of time. We can hypertune our resources using AutoGluon like CPU, memory, as Prajwala mentioned. So with that, we in less amount of time, we can predict disk failure in advance. And this helps us to manage and this helps us to use our backup or our storage system efficiently. Now, this brings us the question that how to leverage AutoML in storage system. Let me tell you. To leverage AutoML in our system, we can leverage it by instructing it to train the data sets whenever needed. resulting in customized model for a specific data set. This will eventually result in every system is having its own model based on the data trend and based on the evaluation metric range. Inside a storage system, as you can see in the algorithm, data set, resource restrictions, and evaluation matrix will be provided, and we will be validating these. If there are saved model which can be used for the given data set, then AutoML will leverage those saved model. If we don't find any model which can be used for the given data set, then AutoML needs to be instructed to train the given data set with the resource restrictions and metric range provided, and give the accurate model that gives good predictions. Newly obtained model will be saved with the data trend and the applied resource restrictions for future purpose. This above algorithm can be enhanced for the cases where AutoML is not able to predict the accurate models with instruction, resource restriction, and components can try with the relaxed resource restrictions if feasible, and the use cases which it is exposed to. Through this algorithm, though this algorithm is derived out of our trials, it can be used in any computer system. We did our trials on an enterprise storage system, so this can be used with any resource restricted environment according to the use case. Now, let me tell you what kind of challenges and what are our next step we observed during our trials. So we observed these major challenges. First one is minimum set of data needed for model selection. As we know that if in a freshly installed system, enough amount of data will not be present, and with that, or it makes difficult for AutoML to learn. So we need to instruct AutoML that train those algorithms which can give the best result with less data, and store those results. And this way we can we need some mechanism to address this challenge, and we will be doing it with more trials. Next, our challenge we faced was time taken for retraining. So in our enterprise storage system, the prediction response should be very fast. But in some cases, when data set varies completely or it varies a lot from the trained trend, then we have to retrain it again, and which takes additional time for AutoML to get to a new model. Next challenge which we observed is for customized model per system, where we know that gradually every system will be having its own model per data set trend. So we need some system specific tracking which is needed for debugging, so that we can handle any kind of system with any kind of data set they are coming with to AutoGlue on. Next, we can see a dynamic data trend. It is also again a challenge to data trends can be compared with existing trend, so that existing saved model, if trend matches, we can leverage those. But it needs some approaches to store and compare the data trends, along with some techniques to search and detect applicable model according to the data set. So these are some challenges which we will be addressing in our trials, and we have some next steps for this. Using AutoGlue on, we can evaluate data sets for additional real-time problems in production storage system, like replication completion prediction, recommendation for backup policy scheduling, etc. We want to bring ML communities focus to discuss on different type of use cases where we can apply ML at scale. With this, here are our references. We would like to thank each and everyone here. And this is our team. It is a team of 5 members. I would like to thank all of them for our experiments. And with that, it brings me to end of our session. I would like to thank Nia for giving me this opportunity to share our experiment with all of you. Thank you for showing your interest and listening to me. Thank you all.